Welcome to the video explanation of the Chapter 4 test review for Honors Geometry. So as we go through this, I obviously would like for you, if you had some things incorrect on your review, to take the time to go back through the process, make corrections or adjustments as needed, and also leave yourself any notes or information you feel will be helpful on the upcoming Chapter 4 test. So obviously the test is on lessons 4.1 through 4.7. So you will need to remember how to reflect points, shapes, as well as doing rotations or translations. So if we look at number 1, draw and label the reflection of points A, B, and C over line L. So B is on line L, so B prime would also be in the same spot. A over line L, you want to draw a line segment perpendicular to L, measure how far A is from the line, and A prime would go on that opposite side. Same thing with C, draw your perpendicular segment, measure the distance from C to line L, and then on the opposite side, place that distance for C prime. If you struggled with this one, I'd recommend going back to the lesson on how to draw the reflections and watch that construction video. In 2, they say consider triangle TRI with the following coordinates: T at 6, 7, R at 8, 0, and I at 1, 3. So TRI is this light blue triangle that I've drawn here. Then that takes care of part A, plotting TRI. Part B says plot T prime, R prime, I prime, where that is a reflection of the original triangle over the y-axis. So then T, R, and I prime are part of this red triangle over here. Their coordinates would be negative 6, 7, negative 8, 0, and negative 1, 3. Because you take the original coordinates and you would change the sign of the x value to flip over the y-axis. And then in part C, plotting T double prime, R double prime, I double prime, where that is a reflection of the original triangle over the line y equals 2. So that would be over a vertical line at y equals 2. Or not vertical, sorry, horizontal. My apologies. A horizontal line at y equals 2. So we're going to go over the horizontal line here. So then we would have to figure out how far away T is from y equals 2. And that would be 4 units away. So then on the flip side, T double prime would be 4 units away from y equals 2. Or 5 units, my apologies again. 7 minus 2 is 5. I can do math. Then you do the same with R. R is 2 away from y equals 2, so R double prime would be 2 away on the opposite side. And then I is simply 1 away, so I double prime would be 1 away on the opposite side. Now moving to 3, they give us a figure that's already been reflected. Like it says, one of these lightning bolts is a reflection of the other. They want us to draw the line of reflection. So the easy way to do this is to connect corresponding points on both lightning bolts. And you need to do that to create 2 segments. So I connected the bottom points, and then I connected the top interior corresponding points. Then what you do is you find the midpoints of those 2 segments. So find the midpoint of this one and the midpoint of that one. And then you draw a line connecting those midpoints, and you have created the line of reflection. So it's connect corresponding points on the 2 figures, to create two different segments. Find the midpoints of those segments, connect them, and you have your line of reflection. In 4, now we're dealing with the mini golf reflections again. So they're saying on the mini golf hole at the right, draw a path that ball B can take to roll into hole H in one single shot. So if I'm looking at that, obviously there's no direct path from B to H. So what I would think is I would need to hit B so that it bounces off the side wall, then the top wall, and then into H. So I need to do my reflections in the reverse process. So I would take point H, reflect it over the top to get H prime. And then you would take H prime and reflect it over the side, which you'd want to extend. So H prime reflected over that side to get H double prime. Then to draw your pathway, you would aim from B at H double prime until you hit that wall. Then from where it hits the wall, aim at H prime, draw until you hit that wall, and from where it hits that wall, into hole H. And again, on the billiards and mini golf lesson, there are video examples walking you through this process. In 5 to 7, points P, D, and Q are non-collinear points. None of these three are on line M, and P prime, D prime, Q prime is a reflection of PDQ over line M. What they want us to do is determine whether each of the following statements is true or false. If it's true, give a reason to justify it. If it's false, they want you to draw a counterexample. I'm not worried about the actual drawing of the counterexample. You can just tell me if it's false or not. So in 5, PD is equal to the distance P prime D prime. So the distance between P and D would equal the distance between P prime and D prime. That's true because we're using the same corresponding points, and reflections preserve distance between points. Then what they're saying is that P to P prime is equal to Q to Q prime, and that would be false. And if you were to draw a counterexample, and I apologize, drawing straight lines on here is not easy, but if this was our line of reflection, if point P was here, P prime then would be roughly right about here. If Q was here, Q prime would be right here. So the distance from Q to Q prime, that distance, is not equal to the distance of P to P prime. So that could be a counterexample if you needed to draw one. Many different ways you can draw the counterexample. On the test, if they ask for a counterexample, I would like for you to draw one. So this could be an easy counterexample. This would be P. This point here then would be P prime. Down here would be Q. And this would be Q prime. So you can see they're obviously different distances, and this would be our line of reflection, M. All right, moving down on to page 2. 7 also goes with the same problem up here. So on 7, it says that segment PP prime is perpendicular to M. And that is true as part of the definition of a reflection. Any point reflecting over a line, then that segment of PP prime is always perpendicular to the line of reflection due to the definition of a reflection. In 8, determine the isometry which maps the figure onto the other. So in A, obviously they're just starting to spin that flag. So that would be a rotation. And in B, to go from one foot to the other, you can see the big toe flipped. So my orientation changed. So I know it's a reflection. But if it was a reflection, this foot would end up right here. So because they flipped and then they slid it, it would be a glide reflection. All right. In 9, name 3 properties that are preserved by all isometries or isometries. And you can take these straight from your notes. What is preserved would be angle measure is 1, betweenness is a second, distance is a third, and there's actually a fourth, which is collinearity. So you could pick 3 of any of those 4. In number 10, name an isometry that preserves orientation. So orientation is not always preserved, but translations or rotations preserve orientation. So either one of those could be your answer. In 11A and B, it says in the figure at the right, B is an image of A under a transformation. So starting at A, ending at B. Write the transformation as a composition of reflections over lines J and K. So A was first reflected over J, then reflected over K to end up at B. So our composite notation would be a reflection over K following a reflection over J. Whichever one is first goes on the right. Then they want us to write the transformation as a translation, including magnitude and direction. So you could write it out in words and simply say it's translated 8 units left, or we could use vector notation, and inside those kind of pointed brackets, it would be -8, meaning left 8, and then comma 0, up or down 0. Number 12 says in the figure at the right, J prime, K prime, L prime, M prime is the image of JKLM under a glide reflection. Line S is the line of reflection. Draw the translation vector. So here's the easy way to do this if it's a glide reflection. If it was just a translation, we could just connect corresponding points and be done with it. The thing you want to do first is choose any one point off of JKLM to reflect. So I reflected L over here, and that became, in this case, L double prime, because L prime's right here. Then from L double prime, I draw a ray starting at L double prime going to L prime. Put your tip at the end of that, and L double prime to L prime is your vector. If you wanted to shift it out of the problem, you could shift it over, but then this drawing has to be parallel to the original vector, so I would just leave it right here. So it would work no matter which point you reflect. If you reflected J over here to get J double prime, then you would draw the vector from J double prime to J prime. Make sure you draw the vector arrow going from the original toward the new. 13, they want us to take the kite, K-I-T-E, reflect it over P, and then reflect that over Q. So K-I-T-E first gets reflected over P, which gives me this blue K prime, I prime, T prime, E prime. Then that blue one gets reflected over Q to give me my final image, K double prime, I double prime, T double prime, E double prime. So a series of 2 reflections. In 14, it just says draw 2 lines so that the composite of the reflections over these lines is a rotation of 90 degrees. Now, they didn't say if it's a positive or negative direction, so that doesn't matter. So what I know is that if my rotation is 90 degrees, the angle measure between the 2 lines has to be 45. So it doesn't matter how you draw it. as long as the two lines intersect at 45 degrees. In 15, it says, for which set of three lines is a composition reflection over U following reflection over V following reflection over W a glide reflection? So which option below, A, B, or C, would give us a glide reflection? It would be C, the one that intersects at 3 different points. So C is our glide reflection. Numbers or letters A and B would both give us reflections, not the glide. And then 16, A, B, and C are real world or real life examples of geometric transformations. So we're matching a transformation that goes with each situation. So moving a picture frame to a new location on the same wall. So you're just going to be technically sliding that picture along the wall. So that would be a translation. In B, bouncing a basketball off the backboard. Well, bouncing something, it's obviously going to bounce back, which would be a reflection. And then in C, the motion of a spoke on the wheel of a bicycle. You know, the spokes spin around the axis. So spinning around a fixed point would be a rotation. And then number 17, you can cross off because that has to deal with lesson 4.8, which we're not worried about. So based on this review, again, to properly prepare for the test, I would make any changes you need to your copy of the review, and then also make sure that you have the note sheets from 4.1 to 4.7 ready for testing day.